this is Gas Laws Lecture 4, Gay-Lussac's Law. So what Gay-Lussac's Law is doing is relating pressure to temperature. So what we're going to keep constant is our volume. So let's say we have a container here which has a fixed volume. Okay, the volume can't change. If we increase the temperature, the gas particles are going to start banging against the walls of the container, and we're going to increase pressure. Okay, we're inserting energy in the form of heat, increasing temperature. We're going to cause the gas particles to have more collisions with the walls of their container. Therefore, pressure is going to increase. So, if this is a direct relationship, that means if we have an initial pressure and an initial temperature, these are going to be directly proportional to our final pressure and our final temperature. So if I increase pressure, temperature must also increase. The only way I can increase pressure is if temperature is increasing. Now what we're going to hold constant is this is going to be at a constant volume. Okay, so let's say that we have a container which has a fixed volume of 3 liters. Okay? The pressure is 2 atmospheres at 25 degrees Celsius. Okay, and we'll say that we raise the temperature, so the final temperature is raised to 100 degrees Celsius. Okay, and we want to know what is the final pressure. Okay, so we're going to go ahead and write our variables. Now if it's at a fixed volume, volume doesn't come into play anymore. We're keeping that constant. So I'm going to have a P1, a T1, a P2, and a T2. Okay, so my initial pressure in the container is 2 atmospheres. Okay, my initial temperature is 25 degrees Celsius. But we know gas laws, we have to have everything in Kelvin. So if we convert this into Kelvin, we get 298 Kelvin. Okay, we're solving for our final pressure, so this is our unknown. And our final temperature, we raised it to 100 degrees Celsius. So this is going to be 373 Kelvin. Okay, now we have our variables, so let's solve for our unknown. So our P1 is 2 atmospheres, divided by our T1, which is 298, equals our P2, which is our unknown, okay, divided by 373 Kelvin. Okay, now notice that our units, if my pressure starts off in atmosphere, my final pressure is also going to be in atmosphere, so those have to match. Okay, so we're going to cross multiply here, so we're going to have 373 times 2 atmospheres divided by 298 Kelvin. Okay, this is going to give us our P2. We punch all that into the calculator. P2 equals 2.5 atmospheres. Okay, so in conclusion, we raised the temperature. Okay, so if we raise the temperature, our pressure must also increase. Our pressure increased because we started with 2 atmospheres and the final pressure was 2.5 atmospheres.